So, welcome friends. In today's session, we are going to learn very important concept of volumetric analysis or titrimetric analysis. Okay. So, when reaction gets completed, the completion point is known as end point or equivalence point or neutralization points. Okay. So, these are nothing but the completion points in the volumetric analysis. Now, question arises: are they same or different? Are they same or different? Let us see one by one. First concept is endpoint. So endpoint means the point at which indicator changes its color during a titration is called as end point, or the titrimetric point at which indicator changes its color during a titration is called as end point. For example, let us consider the titration between strong acid HCl and strong base NaOH. So we, we take HCl and phenolphthalein indicator in conical flask and NaOH in a burette. When we titrate this solution against each other, then we get pink colored solution. Here you can see that. So this pink color, initially the color of this solution was colorless. At the end point, the solution turns pink color. Okay, this burette solution contained the NaOH solution, and this conical flask initially it was containing the HCl and phenolphthalein indicator. This was the colorless solution, and when end point is reached, when reaction gets completed, then color of solution gets changed, and this point is called as the end point of the solution. So definition of end point is that the point at which indicator changes its color during a titration is called as end point. Never forget this definition. Now let us move ahead. Second point, equivalence point or theoretical point. Equivalence point or a theoretical point. So it can be defined as the point at which equivalent quantities of acid and base reacts together during a titration is called as equivalence point. The point at which equivalent quantities of acid and base reacts together during a titration is called as equivalence point. Okay, let us understand with the help of example. Same example, titration between strong acid and strong base HCl and NaOH. When 25 ml of 0.1 normal HCl, its number of milli equivalents will be volume into normality is equal to 2.5 is added to 25 ml of 0.1 normal NaOH. Let's say its milli equivalents will be 25 into normality equal to 2.5, and equivalence point is achieved. So here if we consider total concentration, total number of milli equivalents. Okay, how to calculate milli equivalents? Volume upon normality. Okay, what is the formula of normality? Normality is equal to number of milli equivalents divided by volume. So just rearrange the equation, rearrange this formula, we get number of milli equivalents is equal to 25 into 0.1 is equal to 2.5, or millimoles. We can consider millimoles or milli equivalents, both are the same concept. So this 2.5 milli equivalents when added in 2.5 milli equivalents of base, then an equivalence point is reached. Okay, so equivalence point we can calculate theoretically without doing a practical, or without doing a titration. We can find out, we can estimate where I can get the end point or equivalence point of my titration. Okay, this is the beauty of this theoretical calculation. In next lecture we are going to do all this kind of calculation, how to find out end point of a titration without doing a practical. Okay, so what is definition of equivalence point or theoretical point? It is the point at which equivalent quantities of acid and base reacts together during a titration is called as equivalence point. Let us move ahead. Third point. Okay, one more example is there. If 25 ml of 0.2 नॉर्मल HCl. Okay, ह्याचे जर आपण मिली इक्विव्हॅलंट कॅल्क्युलेट केले, इफ वी कॅल्क्युलेट इट्स मिली इक्विव्हॅलंट, then it will be 25 into 0.2 equal to 5.0. So 5.0, these are the milli equivalent of acid, is titrated with, look at the concentration, here is the 0.1 normal NaOH. Then equivalent point is achieved after addition of 50 ml of NaOH. If the concentration is 0.2 ml, then equivalence point will be achieved after the addition of 25 ml of the NaOH in this case. Okay. कसं काय केलं बरं मी इथे बघा, नंबर ऑफ मिली इक्विव्हॅलंट कसे काढले, कॉन्सन्ट्रेशन काय होतं HClचं 0.2 नॉर्मल आणि व्हॉल्यूम किती 25. सो 25 into 0.2 is equal to 5.0. In this case 50 into 0.1 equal to 5.0. Okay, in this way we calculate the equivalence point. Third point, neutralization point. Okay, what is definition? The point at which the pH of solution exactly becomes 7 during a titration is called as neutralization point. The point at which pH of the solution exactly becomes 7 during a titration is called as neutralization point. For example, in a titration between strong acid HCl and strong base NaOH, the pH of solution becomes exactly 7 when equivalent quantities of acid and base are reacted with one another. या दोघांचं जर टायट्रेशन केलं, सेम कॉन्सन्ट्रेशनचं 0.1 कॉन्सन्ट्रेशन केलं, तर एंड पॉइंटला आपला पीएच किती तयार होतो, pH of solution becomes 7, and this point is called as neutralization point. The point at which pH of the solution exactly becomes 7 is called as neutralization point. So these three concepts are very, very important. In many times, one mark question is asked, define equivalence point or defines neutralization point or define end point. Okay, so always remember its definition. So next topic, what is indicator? What is indicator? Something which indicates, something which gives us idea about the titration is called as indicator. Okay, reaction complete झाली का नाही, whether reaction is completed or not, how to identify it? These are identified by using certain kind of substances or certain kind of solutions which gives indication about completion of reaction. So such compound is called as indicator. Now what is the chemical definition of indicator? Indicators are the substances of weak acids or weak bases which are used during titration to find out end point or equivalence point or the neutralization points. So generally to find out end points, indicators are used. Equivalence point, these are find out by using the volumetric instrumental analytical techniques such as pH metry, conductometry, potentiometry, colorimetry, etc. These are the instrumental techniques, yeah, which are used for the determination of equivalence point or the neutralization point. But end point can be find out by using simple indicator solutions. So definition of indicator, these are the substances of weak acids or weak bases which are used during a titration to find out the end point. For example, there are two type of indicators, one color indicator and two color indicator. So what is one color indicator? An indicator which is colorless in one medium and colored in another medium is called as one color indicator. ओके, ज्या इंडिकेटरचा, जे इंडिकेटर एका मीडियम मध्ये कलरलेस असतं आणि दुसऱ्या मीडियम मध्ये कलर्ड असतं इज कॉल्ड ॲज वन कलर इंडिकेटर. एक्झाम्पल, phenolphthalein. This is the famous indicator we use in our laboratory for the titration between acid and base. Phenolphthalein is colorless in the acidic medium and it is pink colored in a basic medium. When solution turns basic, phenolphthalein starts showing the pink color. We have noticed that and we have done this practical so many times during our laboratory hours. Okay, so this indicator is called as one color indicator. So कोणाला म्हणायचं one color indicator? The indicator which is colorless in one medium, here phenolphthalein is colorless in acidic medium and colored in another medium, is called as one color indicator, right? Second concept, two color indicator. An indicator which has different colors in different medium is called as two color indicator. An indicator which has different colors in different medium is called as two color indicator. For example, methyl red. Okay, this indicator you might have used in the botany labs or microbiology lab. Methyl red, methyl orange, right? So this methyl red is pink color in acidic pink color in acidic medium and yellow color in basic medium. It shows two color, right? So different media, when media changes, color of indicator changes. So two colors in two different media. This indicator is called as two color indicator. Definition: an indicator which has different colors in different medium is called as two color indicators. So question is asked, define indicator, what are types of the indicators? Define indicator, what are the types of indicator? 2 or 3 marks questions. So what is indicator? Indicators are the substances of weak acid or weak bases which are used during the titration to find out end point. Type of indicator, one color indicator and the two color indicator. So write with, give some explanation and give one example, compulsory one example. Now let us go ahead. Theory of indicators. So as we have seen, what are the indicator? Indicator are the substances of weak acid or weak bases which are used in titrations to show the endpoint. So this is the weak acid indicator. So H represent the acidic form of the indicator. IN means the indicator. When it is dissolved in a solution, it gets ionized as H plus plus ion minus. Okay, this is the equilibrium arrow, equilibrium solution. This form is called as molecular form or acid form of the indicator. So this is a molecular in nature. So it is called as molecular form or acid form of the indicator. And this form, ion minus, is a ionic form or base form of the indicator. Okay, see carefully. H ion is a molecular form or acid form. Ion minus is a ionic form or base form of the indicator. Pay your attention carefully. Okay. Now this is the equilibrium reaction. When I dissolve this weak acid of the indicator in water, then I will get equilibrium arrow. So when equilibrium is set up in the reaction, then we can calculate the equilibrium constant of this reaction. So equilibrium constant of this reaction is given by the equation. By applying law of mass action, K indicator is equal to concentration of products upon concentration of the reactant. Okay. Now here, this molecular form and ionic form of indicator has different colors in different medium. Just we have seen right now, one color indicator, two color indicator, right? Why the indicator shows different colors, two color indicator? Because in one medium, indicator remains in a molecular form. In another medium, indicator changes its molecular form or it gets converted into the ionic form. Okay, so try to understand this. So why two color indicator shows different colors or two colors? Because in one medium it retains or remain in acidic form or the molecular form. In another medium it's get converted into the ionic form or the base form. Because of this, our two color indicator has two different colors in two different medium. So colors of the molecular form and ionic form of the indicators are different. So this is the equilibrium reaction. Applying law of mass action to the above reaction, so we get K indicator is equal to concentration of product. Okay, here concentration of proton and ionic form of indicator upon molecular form of the indicator, where this K indicator is called as apparent indicator constant. K indicator is called as apparent indicator constant. This is the equilibrium constant. Okay, this is the equilibrium constant. Next, Now K indicator, just we have seen this is by applying the law of mass action. Now we will, what we will do, we will rearrange this equation. हे equation rearrange केलं तर काय मिळेल आपल्याला? Therefore ion minus ionic form and molecular form I will take to the left side. Then I will get H plus, okay, ionic, sorry, proton, concentration of protons, concentration of hydrogen ion is equal to apparent indicator constant into, okay, हे काय will वरती जाईल, molecular form, concentration of molecular form of the indicator upon concentration of the ionic form of the indicator. So this is the molecular form and this is the ionic form. So next I can write concentration of hydrogen ion is equal to apparent indicator constant upon is into acid form of indicator divided by base form. हे कशावरून मी घेतलं, जस आपण जे मगाशी रिएक्शन बघितली. Okay, this is the molecular form of the indicator and this is the ionic form or the base form of the indicator. So H ion, काय H ion is acid form दिलंय. Okay, this is the molecular form or acid form. I can write here molecular form of the indicator and here as a ionic form of the indicator. Okay. नाव टेकिंग लॉगॅरिथम ऑफ बोथ साइड, ही जी रिॲक्शन दिली ह्याचा आपण काय करूयात, लॉगॅरिथम घेऊयात. मग आपल्याला काय मिळेल, ओके, डाव्या साईडचा लॉगॅरिथम आणि उजव्या साईडचा लॉग मी घेतला आणि लॉगचं काय केलं मी ते सिम्प्लिफाय केलं. लॉग ए इंटू बी इज इक्वल टू लॉग ए प्लस बी. सो लॉग ऑफ एच प्लस आयन कॉन्सन्ट्रेशन इज इक्वल टू log of apparent indicator constant plus log of concentration of acid form of indicator upon concentration of base form of the indicator. आता मी काय करतो, मायनस साइन यातनं बाजूला काढतो किंवा दोन्ही बाजूला काय करतो, मायनस साइन नी मल्टिप्लाय करतो. तर मला काय मिळेल, therefore minus log of h plus is equal to minus log of apparent indicator constant minus log of acid form upon base form. Now we know that negative log of concentration of hydrogen ions is called as pH of the solution. What is pH? pH is equal to negative log of H plus ion concentration minus negative log of apparent indicator constant किंवा equilibrium constant is called as pK value. pK value, and here it is called as pH value, right? So next equation we can write, therefore pH is equal to pK indicator minus log of acid form upon base form. So what is pH? pH is equal to negative log of H plus ion concentration, pK indicator, which is equal to negative log of apparent indicator constant. Okay, where here below you can write down pH is equal to negative log of H plus ions and pK indicator is equal to negative log of K indicator constant. Now from above equation, it is clear that the color of indicator, which depends upon ratio of molecular form or acid form of indicator and ionic form of the indicator, and it is directly dependent upon hydrogen ion concentration किंवा it is pH of the solution. So when this ratio changes, then color of indicator changes. Or why indicator shows color? Because of the concentration of acid form or base form of the indicator, and this ratio is nothing but the pH of the solution. So we can make a generalized statement that color of indicator depends upon pH of the solution. Color of the indicator depends upon the pH of the solution, or color of indicator depends upon concentration of hydrogen ion, concentration of the hydrogen ions, right? Now when we are able to see the color, आपले डोळे कधी कलर बघू शकतात, the human eye can notice color change only when, लक्ष द्या, only when concentration of one form of indicator is 10 times more than that of other form of the indicator. म्हणजे काय, the concentration of acid form of indicator equal to 10 times concentration of base form of indicator असेल तरच आपल्याला कलर, आपले डोळे, आपण आपल्या डोळ्यांनी कलर पाहू शकतो, कलर मध्ये बदल झालेला आपण पाहू शकतो. किंवा concentration of base of indicator is equal to 10 times concentration of acid form of the indicator. So in short, okay, when concentration of acid form or base form, if concentration of acid form is 10 times more than base form, then and only then we can notice the color change. Then and only then we can notice the color change. Hence we can say that, in another word, we can say that our human eye, the human eye can notice the color change only when the ratio of acid form of indicator to the base form of indicator, or base form of indicator to the acid form of indicator is minimum 10 or more than 10. Minimum 10 or is equal to or greater than 10. You can say like that also, right? So if I put this value in the equation, pH is equal to pK indicator minus log of acid form upon base form. Okay, if I put this value of this ratio is minimum 10, then I will get pK indicator equal to minus 1, right? pK indicator minus 1, or pH is equal to pK indicator plus, okay, वरती नेला बेस फॉर्म, तर बेस फॉर्म अपॉन ऍसिड फॉर्म, बेस फॉर्म जर 10 असेल तर I will get plus 1, right? Minus 1 or plus 1. So in short, we can write that pH is equal to pK indicator plus minus 1, right? Plus minus 1. So what is meaning of this? When pH of solution changes by 1 unit, either it is increases by 1 unit or minus means decreases by 1 unit, then and only then human eye can notice the color change. Then and only then human eye can only notice the color change. ओके, म्हणजेच पीएच सोल्युशनचा पीएच जर 1 युनिटने वाढला किंवा कमी झाला तरच आपल्याला डोळ्यांना बदललेला कलर दिसू शकतो. ओके, त्यापेक्षा दिसत नाही. म्हणजे पीएच 0.1 ने चेंज झाला, कलर चेंज आपल्याला दिसणार नाही. पण पीएच 1 ने चेंज झाला, 2 ने चेंज झाला, 3 ने चेंज झाला, then we can notice the color change. Okay, this is by mathematical equations, right? And this range, okay, this range is called as transition range of an indicator. So it is clear that indicator will show color change only when pH of solution changes by 1 unit. Indicator will show color change only when pH of solution changes by 1 unit. लक्ष द्या, समजून घ्या. This is very much important concept. This color change interval in pH units is called as transition range of indicator. Okay, this is very important. This color change interval in pH unit is called as transition range of the indicator. Transition range of the indicator. So question is asked, define indicator, explain theory of indicator constant. Okay, explain the theory of indicator constant, or define a transition range of indicator, or explain the transition range of the indicator. If this question is asked for 3 marks, then you need to write definition and you need to derive this equation. This is simple equation. Okay, it is not difficult, not at all difficult equation. काय काय केले आपण? Okay, let us revise that. So this is the theory of indicator constant. So molecular form is in equilibrium with its ionic form and hydrogen ion concentration. These two different form have different colors. So applying law of mass action to the above equation, we get K indicator constant is equal to H plus upon into IN minus upon molecular form of the indicator, right? So then rearrange the equation for hydrogen ion concentration. K indicator constant is equal to HIN upon IN. So this HIN is nothing but the molecular form of indicator. IN is nothing but the ionic form of the indicator. Now take the logarithm of the both side. Then we get this much. Minus sign common काढला. Okay. Negative log म्हणजेच pH. Negative log K indicator is equal to pK indicator minus log of acid form upon base form. So this equation shows that, okay, this ratio means color of indicator depends on the pH of the solutions, and we can notice color change only when this ratio is this value of this ratio is 10, minimum 10 or more than 10. Okay, so this putting this value, we get this value, and this pH is equal to pK indicator plus minus 1 is nothing but the transition range of an indicator. Okay, now let us move ahead. What is what are the different indicators and its transition range? Now this table represents serial. These are the, I think, 20 indicators you have in syllabus, 20 to 22. Indicator name in this column, pH transition range of the indicator, color of acid form or molecular form of the indicator, color of base form of the indicator किंवा ionic form of the indicator. ऍसिड सोल्युशन मध्ये इंडिकेटरचा कलर कसा असेल आणि बेसिक सोल्युशन मध्ये इंडिकेटरचा कलर कसा असेल. सो दिस 5 indicators, क्रिसॉल रेड, ऍसिड, थायमॉल ब्लू, मिथाइल येलो, मिथाइल ऑरेंज अँड मिथाइल रेड. ओके, ही रेंज जरी तुमच्या लक्षात नाही राहिली तरी हरकत नाही. ओके, बट यू मस्ट रिमेंबर इंडिकेटर नेम अँड कलर ऑफ ऍसिड अँड बेस फॉर्म ऑफ द इंडिकेटर. सो हे मी सेग्रिगेट केलेत लक्षात राहण्यासाठी. ठीक. सो दिस 5 indicator, it has red color in acid solution and yellow color in basic solution. Okay, so acid form of indicator has red color and base form of indicator has the yellow color. You take out the screenshot and later you can write down in your notebook. So these are the different pH transition range. Okay, now what is meaning of this? Let us consider cresol red acid. Okay, this is the acidic component of cresol red. Here is cresol red also there, and here is cresol red. This is the basic form. Here acid form. Okay, so pH transition range of indicator is 0.2 to 1.8. When pH of solution changes, okay, it comes around 0.2, then red form of indicator gets converted into the yellow form. 0.2 च्या पुढे काय तुमचा कलर कसा येईल इंडिकेटरचा? येलो कलर तुमचा इंडिकेटरचा होतो. ओके, 1.8 च्या तुमचा काय होईल? येलो कलर होईल. आता इथे मिथाइल रेड बिलो 4.2, the color of indicator remains red. Above 4.2, color of indicator becomes yellow. Remember this, right? So next, these are the 4 indicator: chlorophenol red, phenol red, cresol red, basic form, and alizarin. Okay, in acidic form it has yellow color, and in base form typically it has the red color. ह्याच्या रिव्हर्स आहे. ठीक. आता हे 3 मिथिल आहे. ओके, मिथिल ऑरेंज, मिथिल रेड आणि मिथाइल येलो. ओके, मी शॉर्ट फॉर्म कसा लक्षात ठेवला आहे? यू कॅन क्रिएट युअर ओन शॉर्ट फॉर्म. ओके, फॉर मेमरी सेक. ट्रिपल एम रॉय, ROY. ट्रिपल एम म्हणजे एक मिथिल, 2, 3. ट्रिपल एम रॉय, ROY. ओके, इट्स ऍसिडिक फॉर्म इज रेड अँड बेस फॉर्म इज येलो. अशा हिंट तुम्ही लक्षात ठेवा. ट्रिपल एम रॉय, ओके, RY. ऍसिड फॉर्मचा कलर आर आणि बेस फॉर्मचा येलो. अशा वेगवेगळ्या ट्रिक बनवा आणि मला पाठवा तुम्ही. त्यातल्या आपण बेस्ट ट्रिक घेऊयात आणि सर्वांना आपण त्या शेअर करूयात. ठीक आहे. सो लक्षात काय काय ठेवायचंय? इंडिकेटर नेम आणि त्याचा ऍसिड फॉर्म आणि बेस फॉर्मचा कलर काय, हे बऱ्याचदा 2 मार्काला 4 मार्काला क्वेश्चन विचारतात. 4 इंडिकेटरचा 4 मार्काला आणि त्याचा आपल्याला ऍसिड फॉर्मचा कलर आणि बेस फॉर्मचा कलर विचारतात. सो नेक्स्ट indicator. This indicator methyl violet, bromophenol blue, bromocresol green, bromothymol blue, thymol blue. Okay, so it has yellow color in acid form and blue color in the base form. Yellow color in acid form and blue color in the base form. Okay, phenolphthalein, thymolphthalein, and nitraamine. Phenolphthalein, thymolphthalein, and nitraamine. These 3 indicator. Okay, this is a one color indicator, and it is a colorless in acid form, and it is pink, blue, and red brown color in the base form या इंडिकेटरला. सो लक्षात ठेवायला तुम्हाला सोपं आहे. ठीक. So this is a one color indicator, and remaining is this brilliant crystal blue pentamethoxy red. Okay, it has the red color in acid form, blue in base form, आणि हा कलरलेस आहे पेंटामेथॉक्सी रेड. सिमिलरली लाईक देअर. ओके, एकदा दोनदा वाचा, तुमच्या लक्षामध्ये येईल या गोष्टी. ओके, लक्षात काय ठेवायचंय? इंडिकेटर नेम अँड कलर ऑफ ऍसिड फॉर्म अँड बेस फॉर्म ऑफ द इंडिकेटर. नाव लेट अस मूव फर्दर. Okay, next topic is very important topic. Suitable indicator and base indicator. many time a question is asked, what is suitable indicator and what is best indicator, or define a suitable indicator and define a best indicator. Suitable and best. So let us consider what is meant by a suitable indicator. So definition of suitable indicator: the indicator which shows color change when pH change taking place at the equivalence point is called as suitable indicator. Read carefully. लक्ष द्या बारकाईने. The indicator which shows color change when pH change taking place at the equivalence point is called as suitable indicator. We have seen what is equivalence point: the point at which equivalent quantities of acid and base reacts together is called as equivalence point. And at the equivalence point or end point or neutralization point, pH of solution changes, right? So at this point, those indicator which shows color change is called as suitable indicators. The indicator which shows color change when pH change taking place at the equivalence point is called as suitable indicator. For example, let us consider simple titration between strong acid and strong base, HCl and NaOH. The pH change at equivalence point is nearly 3 to 10 pH units. Okay, so in next lecture you will understand, okay, why this pH change range is so much broad, 3 to 10 pH units. So right now you just accept that. So pH change at equivalence point is nearly 3 to 10 pH units. Now the indicators such as methyl orange, its pH transition range is 3.1 to 4.4. Methyl red transition range 4.2 to 6.3. Bromothymol blue transition range is 6.0 to 7.6. Phenolphthalein transition range is 8.3 to 10. Have their transition range between 3 to 10 pH units, right? It means, or that is, they show color change during 3 to 10 pH units of the titration. Therefore, all above are the suitable indicators. म्हणजे या titration साठी हे indicator कसे आहेत सगळे suitable indicators आहेत. Okay? In simple language, ओके अराउंड द पीएच. ओके इथे का आता कर ज्यावेळेस तुम्ही काढेल ना त्यावेळेस तुम्हाला समजेल. आता तुम्ही फक्त ऍक्सेप्ट करा या गोष्टी. इक्विव्हॅलन्स पॉइंटला ज्यावेळेस तो पीएच व्हर्टिकल चेंज येतो जो न्यूट्रलायझेशन कर्वचा, तो 3 टू 10 पीएच युनिट असतो. या दरम्यान हे इंडिकेटर काय करतात, सर्व कलर चेंज दाखवतात. ठीक. सो ऑल दिस इंडिकेटर आर दी सुटेबल इंडिकेटर. आता सुटेबल मधून बेस्ट हा कसा काढायचा ते पुढच्या ह्याच्यामध्ये आपण बघूया. सो व्हॉट इज बेस्ट इंडिकेटर? The suitable indicator which has its transition range around the pH at the equivalence point is called as best indicator, right? The suitable indicator, base indicator हा नेहमी suitable indicator असतो, but suitable indicator may or may not be the best indicator. Base indicator always suitable indicator, but suitable indicator may or may not be best indicator. The suitable indicator which has its transition range around the pH at equivalence point is called as best indicator. Okay, म्हणजे इक्विव्हॅलन्स पॉइंटची जी ज्या पॉइंटला इक्विव्हॅलन्स पॉइंट आहे ज्या पीएचला त्या पीएचच्या दरम्यान, ओके, ज्या सुटेबल इंडिकेटरची ट्रान्झिशन रेंज असते त्याला आपण काय म्हणतो, बेस इंडिकेटर. फॉर एक्झाम्पल, मग आताच एक्झाम्पल घेऊया. The titration between strong acid and strong base NaOH. The pH change at equivalence point is nearly 3 to 10 pH units. Okay, this is the pH change at equivalence point, and the pH at equivalence point for this titration is 7. Okay, हे लक्षात घ्या, pH चेंज आहे आणि हा इक्विव्हॅलन्स पॉइंटला जो pH असणार आहे, न्यूट्रायझेशन पॉइंट किंवा जो एंड पॉइंट किंवा टायट्रेशन पॉइंट, हा pH किती इथे तुमचा 7 आहे. आता मगाचे जे इंडिकेटरचे एक्झाम्पल आपण बघितले, सुटेबल इंडिकेटर कोणकोणचे होते? मिथाइल ऑरेंज 3.1 to 4.4, मिथाइल रेड 4.2 to 6.3, ब्रोमोथाइमोल ब्लू 6.0 to 7.36, and phenolphthalein 8.3 to 10. Okay, now here observe that pH at equivalence point is 7. ओके, इक्विव्हॅलन्स पॉईंटचा pH किती आहे? 7. ओके, आता हा जो pH 7 आहे हा कोणत्या इंडिकेटर मध्ये येतो? ओके, विच इंडिकेटर हॅज दिस pH range? Okay, methyl orange 3.1 4.4, so it has no this transition range, or it has not the transition range of indicator is not around the pH at the equivalence point. Methyl red 4.2 6.3, so this transition range is not around the pH at the equivalence point. Bromothymol blue 6.0 to 7.6, so transition range of this bromothymol blue is around the pH at equivalence point. Phenolphthalein transition range is 8.3 to 10. So this transition range is not around the pH at equivalence point. So only one indicator, bromothymol blue, it has its transition range around the pH at equivalence point. Hence, this indicator is called as based indicator. So therefore, the bromothymol blue transition range 6.0 to 7.6 has pH transition range around the pH at equivalence point 7. Therefore, it is called as best indicator for the titration of HCl versus NaOH. Okay. या बाकी सगळे इंडिकेटर कसे आहेत? सुटेबल इंडिकेटर आहे. सुटेबल मधून बेस्ट कोणता? ज्या इंडिकेटरची ट्रान्झिशन रेंज ही पीएच ॲट इक्विव्हॅलन्स पॉईंटच्या दरम्यान असेल त्याला आपण काय म्हणतो? बेस्ट इंडिकेटर म्हणतो. ओके, सो सुटेबल इंडिकेटर ची ट्रान्झिशन रेंज ही पीएचच्या दरम्यान असेल, पीएच ॲट इक्विव्हॅलन्स पॉईंटच्या दरम्यान असेल तर त्या इंडिकेटरला बेस्ट इंडिकेटर म्हणायचं. इट इज कॉल्ड ॲज दी बेस्ट इंडिकेटर. Okay, so question is asked, define or explain suitable indicator and best indicator. So in that case you need to explain this. What is suitable indicator? The indicator which shows color change when pH change taking place at the equivalence point is called as suitable indicator. इक्विव्हॅलन्स पॉईंटच्या दरम्यान पीएच तुमचा बदलतो आणि तर पीएच बदलत असताना जे इंडिकेटर कलर चेंज दाखवतात त्यांना सुटेबल इंडिकेटर असं म्हटलं जातं. ठीक, आणि बेस इंडिकेटर कुठला? ज्या इंडिकेटरची ट्रान्झिशन रेंज ही इक्विव्हॅलन्स पॉईंटच्या दरम्यान असते, इक्विव्हॅलन्स पॉईंटच्या पीएचच्या दरम्यान असते, त्याला आपण काय म्हणतो? बेस्ट इंडिकेटर असं म्हटलं जातं. ओके, नाव we will see the just heading of the next topic, neutralization curve or titration curve. Neutralization curve or titration curve. Definition: what is neutralization curve? It is a plot of pH as a function of titrant added is called as titration curve or neutralization curve. Plot of pH as a function of titrant added is called as titration curve or neutralization curve. Second definition: it can be defined as a plot of change in concentration of H plus ions as a function of titrant, means burette solution added, is called as neutralization curve or titration curve. Okay, for example, neutralization curve for titration between strong acid and strong base. Okay, it is shown in this figure. Okay, so this is a plot. So this curve, this neutralization curve or titration curve, okay, this is a plot of pH as a function of ml of titrant added. Okay, this is a plot for strong acid, strong base, and this is called as neutralization curve or the titration curve. किंवा आपण असं म्हणू शकतो pH म्हणजे काय? It is the concentration of H plus ions and burette solution. Titrant ऐवजी burette solution added तुम्ही असंही म्हणू शकता या केसमध्ये. Okay, now in our syllabus we have these four kind of neutralization curve for monobasic acid and monoacidic base and monobasic acid. Okay, monoacidic base means it has only one OH minus ions, and monobasic acid, it is only one H plus ions. Just name, okay, don't worry about this name. Now example काय will monoacidic base NaOH will monobasic acid, it is a HCl example. Okay, So first curve, okay, look at in the left corner. This curve is for the strong acid versus strong base. Look at this hump, not the hump. This is a S-shaped curve. Okay, initially pH is less, then slowly increases, and ही जी vertical range आहे. Okay, the suitable indicator definition आठवा. This is the pH change at equivalence point. ही जी range आहे 3 to 10. Okay, this range is the pH change at equivalence point, आणि याच्या एक्झॅक्टली मधोमध हा जो येईल तुमचा तो इक्विव्हॅलन्स पॉइंट येईल एक्झॅक्ट मधोमध. इथून जे सुरुवात होईल या केसमध्ये, ओके, याला म्हणायचं पीएच चेंज ॲट इक्विव्हॅलन्स पॉइंट. हा जो पॉइंट आहे, लेट मी चेक वेदर इट इज पेन. Yes. Okay. So this point and this point, it is called as pH transition range. pH transition range. And at the middle point, it is a इक्विव्हॅलन्स पॉइंट, पीएच ॲट इक्विव्हॅलन्स पॉइंट. या दरम्यान ज्या इंडिकेटरची ट्रान्झिशन रेंज असते पीएच ॲट इक्विव्हॅलन्स पॉइंट, त्याला आपण बेस इंडिकेटर म्हणतो. आणि या रेंजमध्ये जे कलर चेंज दाखवतात या दोन रेंजमध्ये, या दोन पीएच रेंजमध्ये, त्याला आपण सुटेबल इंडिकेटर म्हणतो. सो दिस इज अ कर्व फॉर दी स्ट्रॉंग ऍसिड वर्सेस स्ट्रॉंग बेस. दिस इज द कर्व फॉर न्यूट्रलायझेशन कर्व फॉर स्ट्रॉंग ऍसिड वर्सेस वीक बेस. ओके, इथे हम तुमचा इथे आलेला आहे पीएच. Then third, weak acid versus strong base, and weak acid versus weak base. So all this curve we are going to draw theoretically. We are going to do calculation for each point in coming lectures. So don't miss the coming lectures. सो पीएच हा कसा कर्व येतो हा आपण प्रॅक्टिकली करणार आहोत, बाय कॅल्क्युलेशन करणार आहोत. सो इन नेक्स्ट लेक्चर वी विल नीड नोटबुक, पेन अँड कॅल्क्युलेटर as well as graph paper. Notebook, pen, calculator and graph, these three things are essential for the next lecture. Okay, so